So good evening all. Welcome to Sakal Vidya YouTube channel. So welcome back to all. Okay, today's session is related to both Emcet and as well as Ecet students. The complex numbers are common chapter. Okay, now let us start next concept. Okay, thank you one and all. Right. See, complex numbers part 4. Part 4. Right. So in the last class we have discussed about Euler's formula. Okay. Next, mod amplitude form also we have discussed. Polar form, that means mod amplitude form or trigonometric form, that we have discussed. So today some more important points we shall discuss and some problems also we shall discuss. Okay, right. Now, so we know that the cos theta plus I sin theta so can be written as cis theta or e power I theta. That we had a discussion. This is Euler's formula. Euler's formula. So we had a discussion on this one. Okay, now so let us consider Z1 is equal to R1 cis theta or cis theta 1. Z2 is equal to R2 cis theta 2. Okay. Now how to find out Z1 into Z2? Z1 into Z2. So Z1 into Z2 is equal to R1 cis theta 1 times R2 cis theta 2. This we can write R1 R2. R1 is the modulus of Z1 whereas R2 is the modulus of Z2. So we get like this now, R1 into R2. So this can be written cis of theta 1 plus theta 2. You may get doubt how can we get cis of theta 1 plus theta 2? Very simple manner. So this is nothing but R1 times e power I theta 1. Am I correct? This is nothing but R2 e power I theta 2. If you multiply these two, actually you get see Z1 into Z2 is equal to R1 into R2. Bases are equal, the powers are added. This can be written e power I of theta 1 plus theta 2. That's why we had like this, theta 1 plus theta 2. So now this R1 into R2 is the modulus of Z1 into Z2. Modulus of Z1 into Z2 is equal to mod Z1 into mod Z2. But whereas this theta 1 plus theta 2 is the amplitude of or argument of Z1 into Z2. So now we can formulate it. How can you formulate? Let us see. See, as we have Z1 into Z2 is equal to R1 times R2 cis of theta 1 plus theta 2. So we get these results. Modulus of Z1 into Z2. So if you are asked to find out mod of Z1 into Z2, Z1 and Z2 are separately given. You need not find the product of Z1 into Z1 into Z2. So directly this can be written modulus of Z1 into modulus of Z2. Even this can be extended for product of the more than 3 complex numbers also. Z1 times Z2 times Z3 times and so on Zn. So this modulus can be written mod Z1 into mod Z2 mod Z3 and so on. We can write mod Zn. So let us discuss one example now here. Let us discuss one example. So now let me write one example here. Quote one example. Suppose if Z1 is equal to 3 plus 4i, Z2 is equal to 1 plus I, then what is modulus of Z1 into Z2? For example, this is the question. So let us see the solution now. Solution follows. Now we need not find out Z1 into Z2. So let us find out first mod Z1 is mod of 3 plus 4i. Already it is familiar to you. Already in the complex numbers part 1 we have discussed how to find out modulus of a complex number. Understood now. Already we had a discussion. So this can be written root of real part square plus imaginary part square. 3 square plus 4 square. So this is 9 plus 16. We get root 25 whose value is 5. In the similar manner, let us find out mod Z2. So mod Z2 equals to mod of 1 plus I. This is equal to root of 1 plus 1. This will be root 2. Obviously, we are asked to find out mod of Z1 into Z2. So that is equal to how much we will be getting? So mod Z1 times mod Z2. So that is equal to 5 times root 2, 5 root 2. So in this way we can find out. Okay, now next point we shall discuss. Next point we shall discuss argument of Z1 into Z2. Argument of Z1 into Z2. Argument of Z1 into Z2 is just like logarithm formula. For example, log of xy is there, log x plus log y. In the similar manner, log of Z1 Z2 is equal to, we can write log of Z1, sorry, not logarithms, this is arg of Z1 plus arg of Z2. This can be extended for more than 2 complex numbers also. Argument of Z1 times, Z2 times, Z3 times and so on Zn equal to arg Z1 plus arg Z2 plus arg Z3 and plus so on dash dash arg Zn, we can write it. And one more important thing you need to remember. For example, let Z and Z bar be the conjugate complex numbers each other. Then very important, this is very important concept you need to remember. Arg z bar is equal to minus arg z. So hereafter you can remember this one also. Arg z plus arg z bar is always 0. This is the very important result we need to remember. Okay. So this is Z4. Arg Z1 plus arg Z3 plus arg Z4 plus so on arg Zn. So arg Z bar is equal to complex number is equal to minus arg Z. You always remember. Understood now? Arg Z plus arg Z bar is equal to 0. So you need to remember. So let us discuss one question now, one example. Let Z1 is equal to 1 plus root 3i. Z2 is equal to root 3 plus I. Then arg of Z1 into Z2 is equal to. This is the question. So now we need to find out this question. For example, Z1 is given by 1 plus root 3i, whereas Z2 is given by root 3 plus I. Then we need to find out arg of Z1 into Z2. Okay, next now solution. First let us find out arg Z1. Arg Z1 is equal to tan inverse of b by a root 3. So whose value of root 3 equal to whose value of tan theta equal to root 3? So for theta is equal to what is Sumant arg Z2, remember sir, where arg Z2? Yes. Arg Z2 plus arg Z3 and plus so on dash. Okay, right. This is equal to 60 degrees. We can write pi by 3. Now arg Z2 write down. Arg Z2 is equal to tan inverse. Here b is 1, a is root 3, 1 by root 3. Obviously this will be 30 degrees, pi by 6. This is 30, 60. You will be getting 90. So therefore we are asked to find out here argument of Z1 times Z2. This is equal to formula, let us write it, arg Z1 plus arg Z2. So that is equal to pi by 3 plus pi by 6. 6 is the LCM, 3 2 ja 2 pi plus pi. 3 pi by 6. Obviously this is pi by 2. So we can find out like this. Okay, let's have a discussion. Again, let us consider Z1 is equal to R cis theta 1, that is R times e power I theta 1. Am I correct? Right, next Z2 is equal to R2 cis theta 2. This is R1, sorry, not R, R1 cis theta 1. This is R2, we can write e power I theta 2. Now, Z1 by Z2. Z1 by Z2 is equal to R1 cis theta 1 upon R2 cis theta 2. So that means we can write like this. With the help of this divided by this. So Z1 upon Z2 is equal to, we can write R1 upon R2 e power I theta 1 by e power I theta 2 means a to the power of m by a to the power of n, a to the power of m minus n formula. This we can write e to the power of I theta 1 minus I theta 2, I common theta 1 minus theta 2. That's why this can be written as R1 upon R2 cis of theta 1 minus theta 2. Cis of theta 1 minus theta 2. So that means actually here see, it's very important thing we can discuss. The modulus of Z1 by Z2 is mod Z1 by mod Z2. Argument of this one is equal to theta 1 minus theta 2 means arg Z1 minus arg Z2. That we can write it now. So now we can formulate it. Very important thing. Modulus of Z1 by Z2 equal to, we can write mod Z1 upon mod Z2. And next, argument of Z1 upon Z2 equals to, we can write arg Z1 minus arg Z2. So we can formulate like this. Okay, next now let us do one example. So let us do one example. Example, let Z1 equals to 1 plus I, Z2 is equal to root 3 minus I. Then arg of Z1 upon Z2 equal to, this is the question. Okay, let us do it now. Right. Now the solution. Let us find out arg Z1. Arg Z1 is equal to 1 plus I. 1 plus I means that the corresponding point in the first quadrant is 1 comma 1. 1 comma 1 means first quadrant. We can write tan inverse mod b by a means tan inverse 1 is 45 degrees, pi by 4. Now arg Z2. Arg Z2 is equal to root 3 minus I. Root 3 minus I means actually this lies in the second quadrant. Second quadrant are actually here x is fourth quadrant. Fourth quadrant means you have minus tan inverse mod b by a. That means 1 by root 3. This equal to 1 by root 3 means 30 minus pi by 3. Therefore, we need to find out arg of Z1 upon Z2. This equal to arg Z1 minus arg Z2. We can write pi by 4 minus of minus plus pi by 3. This is equal to how much? 45 plus 60. 45 plus 60 is 105. So 12 is the LCM. 3 pi plus 4 pi. 7 pi by 12 is the answer. Okay. Not 45 minus 30. Root 3 minus I. All of you check your answers now. All of you check your answers. Minus argz2. Argz2 is minus pi by 3. Minus of minus plus, you will get it. Yes, you need to check. Yes, we did mistake here. This is calculation error. Wait. So now this will be minus 30 degrees. Sorry, pi by 6. Absolutely correct. Pi by 6. LCM is 12. 3 pi plus 2 pi. Yes, we need to be corrected this one. 5 pi by 12 is the right answer. Yes. Okay, now all of you can check now. Okay, let us discuss one more example. One more example. So modulus of alpha plus beta I upon beta plus alpha I equal to first option 2, second option 1, third option alpha square plus beta square, fourth option 1 upon alpha square plus beta square. Okay, so what is the answer of this one? So what is the answer of this one? Anybody? Okay, now so let us do this solution now. So mod of alpha plus beta I upon beta plus alpha I. So we know the formula. Modulus of Z1 upon Z2 is equal to mod Z1 upon mod Z2. That means modulus of numerator by modulus of denominator we can write. So this is modulus of alpha plus beta I upon modulus of beta plus alpha I. This modulus is root of alpha square plus beta square. So modulus of denominator is root of beta square plus alpha square. So beta plus alpha square is same as alpha square plus beta square. So that means this gets cancelled. We have 1. So answer is 1. So that means second option is the right option. Second option is the right option. Okay, now let me move to the next concept. Okay, let x is equal to cos theta plus I sin theta. Then 1 by x equals to, what is the value of 1 by x? What is the value of 1 by x? Here see, since we have cos theta plus sin theta equals to e power I theta, Euler's form or Euler's formula. Now we need to find out 1 upon x, that is 1 by e power I theta. So we have one formula in algebra. 1 by x to the power of n means x to the power of minus n. This can be written e power minus I theta. So therefore that is equal to, we can write cos of minus theta plus I sin of minus theta. It's very interesting. Cos of minus theta is plus cos theta. Sin of minus theta is minus sin theta. So minus I sin theta, you will get it. That means we can formulate now like this now. X is equal to cos theta plus I sin theta. That implies 1 by x is equal to, always remember all of you, cos theta minus I sin theta. So remember this one. X is equal to cos theta, okay, plus I sin theta, then 1 by x is equal to cos theta minus I sin theta. Okay, now one more interesting fact. Okay, let x is equal to cos theta plus I sin theta. Then first one, x plus 1 by x is equal to how much? Second, x minus 1 by x is equal to how much? Anybody? Anybody? If x is equal to cos theta plus I sin theta, then what is the value of x plus 1 by x and x minus 1 by x? Have you got it now? Right? Right? Okay, next. 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 Okay. So now x plus 1 by x, since x is equal to cos theta plus I sin theta, obviously 1 plus x is cos theta minus I sin theta. Just we have discussed. See, plus I sin theta minus I sin theta gets cancelled. We have cos theta plus cos theta is equal to cos theta. This is first question. Okay, second one. X minus 1 by x. This equals to cos theta plus I sin theta, and we need to subtract this cos theta minus sin theta from this cos theta plus sin theta. Minus of 1 by x equals to cos theta minus I sin theta. So this equals to cos theta plus I sin theta minus cos theta, minus into minus plus I sin theta. Here what happens now here? Cos theta will be gets cancelled. We have I sin theta plus I sin theta, 2I sin theta. Okay. Now let x is equal to cos theta plus I sin theta. Then first one, x to the power of n plus 1 by x to the power of n equal to second, x to the power of n minus 1 by x to the power of n is equal to how much? This we need to discuss. This we need to discuss. This is very, very important, because these type of questions may be asked for Ecet as well as Eamcet also. The most of the times Ecet examination definitely based on this one question will appear compulsory. Even Eamcet also one question will appear from this one. It will be very, very useful. See, let us discuss. So now we have x is equal to cos theta plus I sin theta. We can write e power I theta. That implies x to the power of n equals to cos theta plus I sin theta all to the power of n. So whose value equal to e to the power of I theta raised to n. So a to the power of m all to the power of n, a to the power of mn. This we can write I times of n theta. This is nothing but equal to cos n theta plus I sin n theta. So similarly, we can have 1 by x to the power of n equals to cos n theta minus I sin n theta. Now you can formulate this one and you can formulate this one. Now if you add these two, I sin n theta, I sin n theta cancel, cos n theta, 2 cos n theta you will get it. If you want to find out second x to the power of n minus 1 by x to the power of n, you need to subtract this one from this one. What happens? Real parts will be gets cancelled. We get 2 times of I sin n theta, you will get it now. So therefore now we can formulate like this. X to the power of n plus 1 by x to the power of n is equal to 2 cos times n theta and x to the power of n minus 1 by x to the power of n equals to, it's very important, 2I sin n theta. This you need to remember. This you need to remember. Okay, now I give some examples. So you will do it now. Examples. Let x is equal to cos theta plus I sin theta. Then first problem, x to the power of 6 plus 1 by x to the power of 6. Second problem, x to the power of 7 plus 1 by x to the power of 7. Third problem, x to the power of 8 plus 1 by x to the power of 8. Fourth problem, x to the power of 100 plus 1 by x to the power of 100. Now fifth problem, x to the power of 2020 plus 1 by x to the power of 2020. This question may be asked because this year is 2020. Right. Sixth one, x cube minus 1 by x cube. X to the power of 5 minus 1 by x to the power of 5. X to the power of 6 minus 1 by x to the power of 6. X to the power of 2019 minus 1 by x to the power of 2019. Okay, all of you just try these 9 questions now. I will check, we will do this problem now. All these questions can be done within a fraction of seconds also, without paper pen. In the examination also you can write as fast as. Okay, right. You check your answers now. I will write. Always you get 2, 2. You remember. 2 cos 6 theta. Am I correct? Right. This is 2 cos 7 theta. 2 cos 8 theta. This is 2 cos 100 theta. This is 2 cos 20 theta. This is very important. 2i sin 3 theta. This is 2i sin 5 theta. This is 2i sin 6 theta. This is 2i sin 2019 theta. Correct? Okay. So now you can check your previous Eamcet bits also, previous Eamcet questions, previous Ecet questions. Definitely one question will appear from this model. That's why I am giving more emphasis on these models. Even this can be useful for De Moivre's theorem also. It's very easy, very easy. Yes. Okay. So now let us discuss next concept. Logarithm of a complex number. Logarithm of a complex number. Logarithm of a complex number. So we talk about now how to find out logarithm of any complex number. Can we find out logarithm of a complex number? That's the question. So let's have a question ourselves. So we can find out the logarithm of a complex number. Generally, up to 10th class, we say that logarithms of negative numbers are defined. In real number system, they are not defined. But whereas in complex number, we can find out even logarithms of the negative numbers also. So being put them in the complex number form, so that we can find out logarithms of the complex number. So let us discuss how to find out logarithm of a complex number. Right. Let us say z is equal to a plus ib. Here where mod z is equal to root of a square plus b square, say r. Next, arg z, say theta, that is equal to tan inverse of b by a. So this we know, basic concepts. So now this can be put in the form of r times e power I theta. Apply logarithms on both sides. Okay. Apply logarithms on both sides. Log z equals to log of r e power I theta. This equal to log, actually we have log of xy equals to, we can write log x plus log y from properties of the logarithms. So this we can write log r plus log e power I theta. Here base is e, actually remember, base is e. This we can write log r plus, and one more formula in logarithms we have, power rule. What is the power rule? Log x to the power of n to the base a is equal to n times log x to the base a, n times. So this can be written now I theta times log e to the base e. In logarithms, we have log a to the base e is equal to 1. Log e to the base e is 1. So, okay, since it is 1, you can write log r plus I theta. Actually, this is the logarithm of a complex number. Logarithm of a complex number. Now, we can substitute r for this value, theta for tan inverse b by a. So that we get now, so log z is equal to log r plus, this is how much we have, I theta. I theta. So now since r is equal to a square plus b square whole to the power of half right down instead of root, theta is equal to tan inverse b by a. So therefore this we can write now log of z stands for a plus ib. So log r is equal to, we can write log of a square plus b square whole to the power of 1 by 2 plus I times tan inverse b by a. So half times half into log of a square plus b square I tan inverse b by a. This is the formulation. So this we need to remember. Everything you just leave it. So just for the sake of your better understanding, I proved this one. Log r is not 0. Log r not 0 because r is the number. How could you get log r is not 0? No. It might be sometimes. Log 1 is there 0. If log 1 is the, then 0. So now let us solve the problem now. So let us discuss one problem. One example. Let us consider z is equal to 1 plus root 3i. Then what is log z? Log z. So now the solution here, a equals to 1, b equals to root 3. So therefore log z is equal to, we can write of log of a square plus b square, 1 plus 3 plus I tan inverse root 3. This is of log 4 plus tan inverse root 3. Tan inverse root 3 is equal to how much? This is 60 degrees. We can write, 30 degrees, pi by 3. So this log 4 equals to, remember, we can write log 2 square, whose value is 2 log 2. 2 log 2 means 2 gets cancelled. We have this equals to log 2 plus I pi by 3. That means logarithm of a complex number is also a complex number. Always remember like that. Okay. In this way, we need to find out the logarithm of a complex number. Okay. I ask you one example. Anybody give the answer now? One more example. The value of I to the power of I equals to, first one I log 2, second log 2, third e power I pi by 2, fourth e power minus pi by 2. Okay, solve this question. So I will wait for 5 minutes. You need to solve this question. Narla log 2 0.3010 is log 2 base 10. It's incorrect because here log 2 means in the sense base e, not common logarithms, Napier logarithm. You need to keep log 2 itself only. Don't write 0.3010. Yes, it's because of r is equal to root of a square plus b square. Right. What is the value of I to the power of I? Complex to the power of complex number. Complex number to the power of complex number. What do you get it? Option 3. Good. Option 3. Right. Option 3. Okay. Why not? R may be 0. No problem. Sometimes. Sometimes. Right. So now the solution. Let us say z is equal to I to the power of I. Apply log on both sides. So log z is equal to, we get I to the power of log I. So we need to find out log I. What is log I? Log I is equal to half times log a square plus b square. Log a square plus b square means 1 plus 0 plus this. How much actually in logarithm? See the previous case. This is the formula. I times tan inverse b by a. I times tan inverse 1 upon 0. This will be undefined. So this is log 1 is 0. You will be getting I pi by 2. So that means I times, you get I pi by 2. Log I is, you get I square pi by 2. I square is minus 1, minus pi by 2. So we need to find out z. Here base e. Therefore z equals to e to the power of minus pi by 2. So fourth option is the right option. Fourth option is the right option. This is tan inverse undefined. Undefined. That is pi by 2. So this is one of the methods, or simple method, shortcut method I will explain. Shortcut method. Shortcut method. So what is the shortcut method means? We need to find out, let us say z is equal to I to the power of I. So don't change the power, index or power. So now this I can be written like this. Cos pi by 2, 90, cos 90 0, plus I sin pi by 2. Sin pi by 2 is 1, so it's equal to I. This is e power I pi by 2, Euler's formula. Instead of this 1, let us write this one. So e to the power of I pi by 2 whole to the power of I. So we have an algebraic formula. a to the power of m whole to the power of n is equal to a to the power of mn. So these two we need to multiply. So this is equal to e to the power of I square pi by 2. I square is minus 1. E to the power of minus pi by 2. So all of you remember, very important, I to the power of I is not a complex number, is a real number. This you need to remember. That means I to the power of I is a real number. Okay. Okay, I ask you one question. Can you prove irrational number to the power of irrational number is a rational number? Can you prove irrational to the power of irrational is equal to rational or real? Rational. Think. You need to prove this one, and you need to thought-provoking question. This is thought-provoking question. Irrational to the power of irrational can be equal to that rational. So if you have that one proof, you can comment on the box. Next, I will discuss the names of the who have solved this one. Irrational to the power of irrational is equal to rational. In the Zoom session, I will declare the winners. This is the today's quiz problem. Every day one quiz I will give it. This quiz. Irrational to the power of irrational is equal to rational, you need to prove. Think. So winners can be declared on the 26th Zoom session, morning session. Okay. So what is log I? What is log I? What is log I? So log I also remember once again. Log I equals to I pi by 2. Very simple. This also sometimes you may be asked directly. So this one and this one you need to remember. Okay. So today we have discussed so many concepts. Don't get any confusion. Once again, just you revise it. Okay. That means even this is the actually mathematics, the beauty of mathematics. What is the beauty of mathematics means? See, even complex to the power of complex number also real. Generally we think, suppose that complex to the power of complex is imaginary, but it's not imaginary. I to the power of I is a one example, wonderful example we shall give it. That's a real number. I to the power of I is nothing but e to the power of minus I pi by 2. See, in the similar manner, you might have noted the quiz, that is irrational to the power of irrational is rational, you need to prove it. Yes, e to the power of I pi by 2 is, sorry, e to the power of minus pi by 2, I to the power of I is this one. Right. Okay, thank you. I hope you might have followed. Tomorrow, the morning, our session will be continued on complex number only. Morning also complex numbers, because actually permutations and combinations completed. So tomorrow morning we shall complete more extensive. So we will solve the problems on this one. That is based on both the levels, Eamcet and Ecet levels. So tomorrow morning 9:30 class is meant for both of you. Okay, thank you. Bye bye.